You should just use those before the Slack poll.
Yeah.
So you just put the logos in there.
All right, cool. Hey, Tom, can you hear me?
Yeah.
All right, cool. Let's go ahead and get started. So welcome to Cool Code Consortium Week 4. Got some good stuff planned for this week. So again, we'll just go through announcements and then make sure that you take a look at the poll. Then we're going to do cool news. Tom has some good cool news for us today. Then we're going to dive into Unity 3D. And Luke is going to tell us all about that. I'll talk about next week, and then we'll do the poll results. So. Okay, couple announcements. Again, we've got a GitHub repo for slides and the demo code. So be sure to check all of that out. Additionally, I didn't put this in here last week, but I think I mentioned it. We did get our last week's video recorded and uploaded to our new YouTube channel, Cool Code Consortium 2018. So check that out if you weren't here or you missed that. Also, the current plan is to record this one and put it up there too. So additionally, Maya has downloaded a bunch of custom Slack emojis for our Slack. So be sure to go check those out and use them. There's a bunch of good stuff in there. So check that out. So I think at this point, we're going to move on to cool news. So Tom, if you want to take it.
All right, is my mic on?
Yep, I can hear you.
All right, so kind of made a big mistake here. I have my slides on one computer, but the mic on theirs broke. So bear with me. I got to talk through one device and slide with the other.
Okay, I think we can make that work. He's got slides on one computer, but mic on the other. So just do the one that he has slides on.
All right. Well, I have a slide. God, it looks terrible too. I should have that.
Okay. Yeah, I see your slide here. So let's hold on 1 second. I'll put this over for everybody here.
Oh, this is a special kind of recursive right here, isn't it? All right, so we all good?
Yep.
All right, so I think this was being published a little over a week ago, actually. I think it was not this Monday, but the week ago from this Monday. Some people at, I believe it was a university in the Netherlands, published a new attack called RAMpage, spelled like that with capitalization like that, with that logo too. It has a logo because it needs that. But what RAMpage is, it's an updated version of an attack called Rowhammer, which I don't know if everyone's familiar with that. If you're not, basically what that is, it's because of the way that DDR2, 3, and 4 memory works, the individual cells that keep a charge to represent bits, they are packed closely enough together that if you can cause a certain one of these cells to update, if you can write to one of these cells enough times, some of the charge stored in that cell can leak over into adjacent cells, causing bit flips in other locations in physical memory. So that's bad, because what that allows you to do is you can potentially cause bit flips in other processes, things like that. So what RAMpage, after this, I think it was something like almost 2 years after this, another tech called Drammer. There's been a lot of work with Rowhammer, but there was another attack called Drammer published, which specifically targeted Android devices, and it worked by basically you needed to be able to allocate large amounts of contiguous physical memory for this to work. and you need to be able to arrange what are called the rows that the rows in RowHammer are the physical rows that memory is arranged into. So you needed to be able to arrange physical memory. You needed to be able to arrange physical memory in such a way that you can have a row of memory that you can write to next to a row of memory that you can't write to but you want to. So that could be things like a process's page table. If you can change bits in that, you can potentially write to other processes' memory or read from other processes' memory to get things like cryptographic keys, other things. Off the top of my head, that's the what I'm thinking of. But Google, after this older attack was published, Google changed how they were handling memory allocation in Android, specifically to not allow you to allocate physically contiguous memory. So virtual memory, you can, it still appears that, you have your virtual memory, it's still, contiguous, but physical memory, those pages could be anywhere. So what RAMpage does is it builds on this work, because it turns out what basically if you exhaust memory enough on the allocator, the memory allocator used by Android is called Ion, and basically if you can allocate enough memory and then cause the amount of memory allocated by the system to shrink, you can still get the physically contiguous memory you need. So that's what RAMpage does. It allocates enough memory to the point where it's not the out of memory killer. Android has a separate system called the low memory killer. The low memory killer comes and it starts, it basically asks processes nicely, can you release some memory for me? They do, and that, because of the internals of how that works, that can cause physically contiguous memory, which is, and then from there you can carry out the same attack still. So, and the same people who published this published a new method for blocking that, but that's less fun than, how the attack actually works. So, any questions about that, or?
I don't think we have any questions over here.
All right. All right, that's all I've got for that. So.
All right, cool. Thanks, Tom. We'll go ahead and move over to Luke.
Why?
All right,
The
so
mic is on.
Yeah, the
so
mic's on. Hardware on Hangouts. Yes.
so we're experiencing some mic issues. So I think I'll be the mic. I'll be Luke's mic. So audio will come through mine, and then just go to Luke's for the slides.
Is that loud enough?
You can.
Yeah, you're fine.
Okay.
Okay.
So I'm just gonna put that here.
Just
Then.
no fun. You know what to say. You know what a script is?
Okay. All right. So, what was I saying?
I guess start from the top.
Yeah. Okay. So I'll be talking about Unity 3D. I have a few slides here, but a lot of it will be done in the editor because it's pretty visual. So I think that shouldn't be boring. Shouldn't be just me writing code for most of it. And it means I have to make less slides. So, all right. So I guess the first question is, what exactly is Unity? It's a game engine, and it gives you a lot of tools for creating your own games. It has a built-in physics engine. Like I said, it has a nice editor. It does a lot of stuff. You can see these three things are all things that were made with Unity. So some pretty high-profile games are made in Unity. Can do 2D like Cuphead. It can do 3D and virtual reality like Rick and Morty. And then the last one's a movie that they made in it. I don't know why they made it in that instead of like something else, but you can do it if you want. But this is probably a good time to also talk about what it can't do. You can't really use it to make these kinds of art assets. Like all of the drawings in Cuphead had to be made somewhere else and then imported. All of the 3D models had to be made somewhere else. You can arrange the 3D models in like space, but you can't, make them in Unity. And same with the textures on them and everything. So it's not, you can't do everything there unless you want your game to just be cubes and spheres, but it handles a lot of the actual game parts of making a game. So yeah, it's pretty flexible. It's pretty powerful. A lot of people use it. Let's see, and I have a picture of the editor here. I don't really know why. I'm about to just go to the editor, but here's a preview for everyone, I guess. Oh,
So guess what? We found out Luke has audio now.
I muted all of my things.
There we go. So you can take over with. All right. How about that? I think we'll be okay there.
Are you unmuted?
I am unmuted.
All right.
Okay.
Sorry about that.
Exactly like that.
Okay. All right. So this is the Unity editor. It's pretty adjustable. You can drag stuff around. If you've ever done work in something like Blender, this will seem pretty familiar with all the different windows. If you haven't, it's not too hard to learn. We'll just kind of step through here and talk about what the things do. So this is the scene view. It's it's standard. You can move around in 3D space with it. I'm not going to do too much with it because I'm using a trackpad right now, and that's just terrible. But it's pretty nice. You can zoom in and out and stuff. And then, so this is where you'll see kind of how stuff is taking shape. But you can still see what the more fully formed game looks like in the game view over here. This actually is tied to the camera. This has a little bit more serious like graphics and effects and everything. it's not as nice as it'll be with the built product, but you get more of a sense through this. If you want to test UI and stuff, this is a good place to do it. And camera and everything. So that's the game view. And then you've got the hierarchy view over here, which just has everything you want, or everything in the scene. So you can see I can select stuff over here and it selects it in the scene view. And all of the little informational stuff I'll get to in a second on the right also changes. And you can add things over here. So you want to add I want to add a sphere over here. You do it by just dropping in there. As you can see, as the hierarchy name might suggest, you can have different parents of children. So you can have groupings of objects under other objects, which allows you to keep your scene very nice and organized, and also will help you with scripting stuff, which will come up in a bit. Yeah, so yeah, a lot of what you do will be kind of just adding stuff in here. You can have empty things that don't really have anything over here, except for maybe a transform, a location in the world that you can use to just group things. Yeah. And then you've got, like I said, all the informational things over here. This is the inspector. If you want to change the position of things like numerically, you can do that over here. So change positions and change scale and rotation. That can all be done over here to a more precise degree than you can do in the scene. It also holds all of the different components you want to look at. So this has a mesh. You can see it, so it has to have a renderer. You can see all that kind of stuff over here. This is also where we'll be attaching our scripts when we get to that, which is a big part of what I'm going to talk about because this is computer science dealio. Code. Okay, and then down here we can see assets and stuff. And this is just basically, it's the project view, but it's basically just where you can see your files and bring in new files and save files that I'll also talk about in a little bit. But so basically, this is just like a mini file browser in Unity that you can mess around with. So yeah, those are all the views. Pretty easy to get used to. When you want to test what your game is like, you can hit this play button up here, and it brings you over to the game view. You can turn off the maximize on play if you don't like that. But yeah, so this just allows you to preview your game, see how it's coming along. It won't be there. Sometimes there are things that will be different when you build it, but again, it's a good preview, and it makes testing so much faster. Okay, so once you kind of get familiarized with all this, you can start looking at how to add things over here. So right now, I've already added this plane and this cube just so we have things to work with. Over here, you can see when I added them, I didn't add anything over here. They just came with the colliders and the materials. And I'm not going to get too into all these components because there's a lot of them. And the tutorials are pretty comprehensive on them. So you can read about colliders and materials and stuff, in your own time if you want to mess with that kind of thing. Colliders are useful. They're used for the physics engine, which is built in and very, important for a lot of games. But we're just going to add a script here. Oh, I already have a script here, actually. We're just going to edit this script up here. So let me bring over my... So over here, we're in good old VS Code. The scripting in Unity, or Visual Studio, not VS Code. I apologize. Yeah, so the scripting in Unity is in C#. They also have JavaScript, I think. I don't know why you'd use that, but you can if you want. But yeah, so C#, if you haven't used it, is very similar to Java. It's about the same level of complexity. A lot of things are actually kind of nicer. Like you can do the same things with less writing, typing. But in general, it should be very familiar. A lot of the syntax is even the same, as you can see. Public class, movement script implements mono behavior. Imports, all that jazz. So yeah, this is our script. As you can see, it implements mono behavior, which is something that you will see all the time in Unity. What a mono behavior does is it's a script that you can attach to an object. You actually can't use it without it being attached to a game object. So this one, as we saw before, was attached to this cube, right? This script is attached to this cube, and so it's a mono behavior because it's attached. And that gives you some functions that you can use to interact with the world of Unity, like this start and update. This throws them in for you automatically when you create a script. So the way this works is Unity works on ticks. So like every so often it updates the game, it updates your frame, re-renders everything. And also it handles, creating all these objects and everything. And so it handles calling these functions here. You don't need to worry about calling start from somewhere else. It happens through Unity, which is kind of weird. It works because it's on top of C++ and it's not really .NET. It's kind of weird, but it does make things easier. It really makes the connections make sense. And there are more of this type of function. Like there's there's fixed update, for instance, which is like update, except it happens every physics tick instead of every frame update. So if you need physics things, that's where you go. There's a lot more of them too, but I won't get into all of them because some of them are pretty subtle in how they differ.
So I think just a side note, people who've taken design, these are kind of like hooks into a framework. You can also think of template method. Basically, some other bigger entity knows about this, and it's doing the invoking of these methods.
Mm-hmm. Yeah, exactly. Like Connor said, it's Unity is a bigger thing that's just seeing these methods and calling them when it needs to. Related, if you don't put anything in these methods, just get rid of them because Unity will see that they're there, even if they're empty, and try and call them, and that adds some overhead. Just a side note. But okay, so say we wanna do something on update. I don't know. Say we want to move it. How do we move it? So because this is a mono behavior, this gives us a lot of extra things to work with. For instance, every mono behavior, because it's attached to an object, also has a transform, because every object in the real world has a transform, or in not the real world, the Unity world. And transforms have things like position and rotation and all that kind of stuff. So say you want to go and just move this up every tick. You move it up every tick. I don't know, like 0, 1, 0. So you just want to move it up like 1 unit every update, every frame. So you would just do something like that. Has to rebuild the scripts every time you switch back. So yeah, not super useful, but that's the kind of thing we can do. Let's see. We can make that less just so you can see it. 0.01.
That's the refresh rate is slightly.
Yeah,
they missed the whole thing. Eh.
0.01. Loading point.
So yeah, you can see it moving. Okay, so that's cool, right? And say so you can, do whatever you want in updates. Usually these would be tied to some sort of input. Let's see if I remember how to do input. This is super long. Rx. Well, let's be bold. Let's do any key. So now I'm pressing a key and it goes up, and I stop and it stops. I hit it again, it goes up and stops like magic, right? So yeah, that's how you hook. That's, you know, in the most simplest way possible. That's how you hook things together in this world. Let's see. So now I'm going to talk about something that is very, very useful, but might be a little different than kind of what you're used to. So Unity is all synchronous. You don't, it doesn't play nice. It's not very thread safe, right? Doesn't play nice with async. And that's because it calls things on ticks. If you mess with those kind of values, it can get weird really fast. So instead, it just calls things on ticks and updates them accordingly, but all that is done synchronously. So that means if you want to say, do something in a little while, do something in a couple of seconds, you can't like start another thread that waits. You can't do that kind of thing. You have a couple of options. One option is on update to have some sort of, you know, variable that's bigger in scope, like maybe a class variable or something, that you update in update until it gets to a certain point, and you check that every update, which a lot of people do. It works great for some things, especially if you do have like a class-wide state that it makes sense to take care of in that state and update and like check. But you can also do things with coroutines. Coroutines kind of just handle that sort of timing logic for you, which is really nice. So I'm going to make a coroutine here. So like public, they need to return IEnumerator because they're kind of a hack on C# iterators. I'm not going to explain it, it's weird, but but all you need is the syntax, really. Okay, so I'm going to call that co because I'm lazy. What? Oh, whatever.
All right.
Yeah. Okay. Yeah, because I haven't returned anything yet. Okay, so the things you can do with this is everything that's done in like start and update happens in one frame. So that means, if you're trying to wait for something that might take longer, you can't do that in any of that logic because you'll slow the whole thing down. It won't be able to render the frame in time, and you'll get stuttering, which is, you know, a big deal in video games. So with coroutines, though, you can skip a frame by doing by returning things. So like if I yield return null, that just skips one frame. So that's useful if you want to say animate something frame by frame. You say like, but you want it to be logically in one place instead of in an update every frame. You want to say like for this period of time or this many frames or until it's at this location, do this frame by frame. Or you can do, they have coroutine things that can give you, you know, more precise timings. Like, say you want to wait 5 seconds, you can do that. And then, you know, of course, have all of your logic around it, like So I want to move up a little bit before, and then, or immediately when this coroutine is started, and then you want to move it more up later. And then you want it to stop or something. And then to call this, you just do start coroutine, and then whatever your coroutine is named. And this is only, you can only start a coroutine in a mono behavior. So you can have other things besides mono behaviors, but a lot of the Unity specific things are only available in mono behaviors, which is neat. So if I save this, so it moved up immediately because it was called on start, and then waits 5 seconds, and then moves up again. Okay. And you can also do things like, you can start other coroutines in here. You can yield return other coroutines if you want them to block until that other coroutine is done, so you can chain them together like that. It's a pretty nice tool for keeping stuff consistent, for keeping logical periods of time, or actions you want to complete over a period of time in a logical place. Yeah, I used it a lot when I was making animations. So like I want to move from here to here, and then when that's done, I want to, rotate or whatever. It's very useful chaining that kind of thing together without having to have a bunch of weird logic and update. Yeah. Let's see. Also, this is related to frames. Frames aren't super consistent. You can, if you want to yield return null and just skip a frame, then you don't really know how long this is. So if you want something to have a consistent movement of, I don't know, like a centimeter per second, you don't really know if that's going to happen if you say, all right, there's 60 frames a second, I'm going to move it a 60th of a centimeter per frame. You don't know, because like there are frame dips.
Yeah, so like, could you like explain that a little bit? So like, maybe why my frame rate may not be consistent throughout my playing of the game.
Yeah. Well, so your computer is trying to do these calculations and render a frame, depending on your frame rate, a certain number of times per second. So like for a lot of systems, that's 60. For some consoles, it's 30. Some people like it up to 144. Whatever floats your boat. But it's trying to keep it consistent and do this a lot. But if there's a lot of, if it's hard to render, I might talk about this more later if I have time. But there are a lot of reasons your game might not be able to hit that benchmark. It just isn't performant enough in some area. So it can't render that fast enough. So it just slows down a little bit and has to skip a few frames. So you can have dips. And there are games that tie some physics calculations to frame rate, and that just causes wonky physics, especially when you're running on lower end systems. It makes it so that like things just kind of go haywire. You don't want to do that. Don't be those guys. So what you can do is, I don't know if this is a good example for this, since we're kind of just randomly moving stuff. But so you skip a frame here. I'm going to do this in update because I think that makes more sense than here. All right, so back to just moving stuff up every once in a while. So you want to say transform. You want to move its position again. Oh, that's not. So we want to still not. Okay, so you want to move it up a certain whatever. So let's say vector 3 again, 0. Actually, what might I just do? So we don't have to keep doing the vector 3 thing. y plus equals. Can I do that? I can't do that. Can you do that? Does it allow you to mess with vector 3s like that? Yeah, you can't return value then. Okay, we'll just keep doing the yeah. Sorry for that goose chase. Let's see. Yeah, we're looking at what we say, centimeter per second, just vertically for whatever reason. New. So you I'm working on it. So you're looking at this and you're like, okay, so that's every time this is called, it's going to add this much to it. But I don't want it to be happening every time it's called. So what you can do is Unity keeps track of a lot of time stuff for you. So it keeps track of the time it takes to render a frame. And it stores that in time.delta time. And so this is super useful for just keeping things consistent across frames. You just multiply your speed or whatever by delta time, and you don't have to worry about that anymore. They have a few other ones, like, I don't remember exactly what they're called because I never used them, but there's like real, fixed delta time. There's other stuff, but because you can scale your time in Unity and like you can pause time if you have a pause menu, that kind of thing. So there are a lot of options, but a lot of them kind of do the same thing. They keep track of the time between frames.
So the idea is that update is called every frame. Delta time is also updated every frame. So that if I lag, like if I miss several frames, then my delta time will allow me to account for that in the computation of update.
It's not even necessarily missing frames, but just having a longer period of time between frames. So like you're like, I expect my frames to, render like a millisecond apart, and it's probably pretty long, but this time they did a couple of milliseconds. This keeps track of that for me and allows me to multiply it so it doesn't change or waver. So yeah, if we do this, we can see that it'll actually be, you probably won't be able to see the inconsistencies before. Compile errors do I have? Oh, go away. You probably weren't able to see the consistency errors problems before, but this way they're all smoothed out nicely. You can see them moving nice and slowly there. Whatever. I don't know what kind of framing I'm getting on this, probably pretty bad. So yeah, it's different thinking about how you want things to update in this kind of world versus like a program that's all your own stuff. You can't really rely on consistency for some of these calls. All right, let's see. How much time do I have? Okay, I've got a little bit of time. Okay, what do I want to talk about? Prioritize. So yeah, okay. So that's a very brief intro to scripting. I could probably talk about a lot of this stuff for quite a bit, but I'm not gonna do that. I will say that. Oh no, there's actually one other important thing I should mention before I get off this topic. So, so you can, of course, you've got fields for a lot of classes. Say I want this to somehow be related to some other object, or I want this script to modify some other thing's position. You want to keep that logic together, or you have some manager object that controls a bunch of other objects. You want to have a reference to that. So you can have a lot of behaviors can just have fields up at the top, and then these fields will actually show up. Sometimes there's some caveats that we've run into, but they actually show up over here. So you can be like, okay, I don't know, plain, whatever, doesn't really matter. So I want this plane to fill that field. You can just drag it over there and drop it and be done. So it's kind of like a poor man's dependency injection-ish, right? Like top level, you just give it the dependencies it needs. You can wire stuff up without coding. Some of the really good components allow you to have events that are modifiable in here, and you can, select objects from across the world space and like do whatever you want to them. And it makes it really nice that you can just like do that from this level and not have to worry about the code. And then go in and edit it here, do whatever you want, change its transform, make it rise even slower if you want, like whatever. There are some caveats though. It doesn't support things like interfaces, which is kind of a pain we've run into. Dictionaries, you've got to do a hack where you make a struct in an array and then on start populate the dictionary. Well, it's a thing.
Well, the other thing I was thinking about is like a constructor. Do these objects have constructor?
No, it's just start. You actually can't. You can't make one with new. Like you can't. It complains. Yeah, that's kind of, it makes testing interesting, which I can talk about a little bit at the end, but you can't just instantiate these things without an object to be tied to.
You can instantiate a prefab, choose save.
Yeah, you can make an object, but then that gives you a lot of performance overhead. It gives you objects you might not want. Maya just mentioned prefabs, which are something I frankly haven't used a ton, but I think are actually really useful if you actually want to do like a game or something. You can save these objects as what are called prefabs, and it just means they're all set up like they are, like with their attached scripts. And they can be whole hierarchies. So if I want this plane and this cube to be a prefab, I can just like drag it down here, and it adds it as a prefab for me. And then you can just instantiate new ones of those, and like, so you say you want like a bad guy, you just make it a prefab, and then boom, 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 like create it in some sort of loop or something, and
I have 100 bad.
And you have 100 bad guys, exactly. So yeah, and then you can update your prefabs. You can see over here, you can like apply the changes to them, and so it makes things really nice to save these kind of constructions. Where was I? I got off topic because of that. But yeah, so this kind of wiring stuff together is really handy, but it does have some problems. I will say that it is really useful. Like you will use this. And you can even have like, say if this field was some other type of script I made, if that script is attached to an object, you can just grab that object and put it in there, and it'll find the script on that object and get it for you. And it only shows up if it's public, or if you do a serialized field on like, serialized field on like a private thing. All of the tutorials I've run into, you just use public when they have this option to like deal with private stuff. So like, be a good coder, use serialized field. And say you have a public object that you don't want to show up in the inspector, because like you don't want someone having to mess with that. You can do hide in inspector. So that allows you to handle that kind of stuff. Let's see, it's gone if I saved. I did not save. Yeah, once this builds, it'll be gone. Question mark. Should be gone. Why it's not gone? Well, I don't know. Just pretend it's gone.
Something else that's selected again.
Maybe because it's the prefab. I'm not sure.
Oh.
I don't know. Whatever. No, we're just gonna pretend that it disappeared. I don't know why that's not disappearing, but you can hide it in Inspector. So yeah, that's useful. They do have frameworks for like actual dependency injection, which I haven't messed with, but like built specifically for Unity. Zenject, if you ever are interested. They have a lot of frameworks externally that are really useful for like animation and assets and all sorts of jazz. They have a nice little store here, so you can find all that junk. Yeah. Let's see. What was I going to talk about next? Let's see. I guess we can talk a little about performance before we get entirely away from like the coding With video games, you do have to be careful to make things performant. And so you've got to watch out for, of course, complex scenes that have a lot of polygons, difficult shaders. You can write your own shaders and stuff. You can do a bunch of stuff. But if it's too much, it will just be slow, and that's no good.
I don't know how much insight you have into this, but like, what's a shader?
Okay, yeah, I won't get too into it because again, it's kind of complicated. But a shader is just the calculation that your graphics card does to figure out what a pixel looks like. So a simple one's just like, from the render, get me this pixel. A more complex one is like, oh, I just want like black and white. So either make this black or make it white, depending on what the light value they return is. More complex ones can like pull pixels around it to like make distortions. Those ones are usually more performance intensive. But yeah, so that's what a shader is. So that's repeated a bunch, every time your graphics card renders a pixel. So you want to make sure those are performant. Yeah, that's like a big thing with performance. And there are different aspects of performance. It can be the graphical aspect, and there's a profiler that I'll talk about in a second, where you can like see where these performance hits are coming from. But when you're coding, you want to keep these kinds of performance hits in mind, especially if there could be spikes. Which brings us to garbage collection. So C# is a managed language, which, as I probably know, there's a garbage collector that cleans up your trash after you don't have any references to it. But when you're trying to render frames consistently, that garbage collection can cause a spike in CPU usage, which then causes a performance hit. So important things to keep in mind, maybe not at like a very early level. Like I don't think we've had any problems that have been caused by that kind of thing, but we have a very simple scene. But as you get more and more things, you got to watch out for that. So you can't cause too many allocations of like reference type objects that will go on the heap. If it's value typed, it's fine, like ints or whatever. But if you have reference types, that can cause a lot of allocations and then deallocations, and that slows down the garbage collection. And the fuller your heap is, the slower the garbage collector is, just doing those operations of allocation and deallocation. So you want to be careful of that. A lot of things can do like sneaky allocations, like strings are actually reference type. So if you like want to print a bunch of stuff to your debug, try and strip that out when you build it, because those can cause a lot of allocations and deallocations, especially if you're trying to like string this plus variable plus string, that kind of stuff can cause a lot of allocations and deallocations. So that's one thing to keep in mind that I think is kind of interesting with this sort of.
Destroy your game object.
Yeah, you want to be careful of destroying game objects when you're finished with them. There's strategies like object pooling, where if you've got a bunch of the same object that you're going to be creating and destroying, instead you just disable one and reuse it at the beginning, so like bullets or something. So there are strategies to like combat that, because creating and destroying an object takes a lot of operations. And that's another reason testing is hard, because you don't want to instantiate an object just to test a mono behavior, because then your tests are going to be super slow, and that's terrible. So yeah, there's a lot of interesting performance hangups, and there are pages and pages of like different little tricks and like things you wouldn't think about that are online, but that's an interesting one. Let's look at the profiler. Let's see where this is. Here it is. No, it came up in the other window.
Aw, that's cute.
So with this profiler, let's see, it tells you where things are being used. It's like CPU usage, rendering, memory, that kind of thing. So this is a really useful tool. I haven't had to dive into this too much, but it's a really useful tool for like seeing where your performance hits are coming from. You can see, okay, is this CPU throttling? If it's not, I probably don't have to worry about my allocations. I can focus on trying to optimize the materials I'm using, or getting rid of polygons.
That whole list in the bottom right would be like, you could think of it as like all your game objects, and you'd be able to like look at statistics and be like, this
exactly, yeah,
game object is taking 50%.
It's not even just CPU, exactly. It's you can look at, okay, so like, oh, it's wait for I can't even wait. Oh, that's actually that's VSync, so we don't care about that. But like, oh, so like this camera drawing is taking up a lot or whatever. You can like narrow it down to exactly what's taking a lot of CPU time or whatever. But yeah, wait for target FPS is just it trying to match your frame rate, which makes sense that it would slow the frame rate down, especially with a scene as simple as this. So they give you a lot of useful tools. They know you're going to be trying to hunt for what you need to do to make your game faster, which is neat. Let's see. Another big performance thing you should watch out for is physics. If you have a lot of collisions and that kind of stuff, that can slow stuff down. If you have a lot of complex colliders, these colliders just mean there is some sort of shape that works with the physics engine. So if it's a primitive shape, like they have box, they have capsule, they have, what else do they have? Do they have like sphere colliders? So a lot of like primitive colliders that are pretty performant. If you try and do a mesh collider that actually fits the mesh of your object, that slows it down a lot. So a lot of times you just try and like do some sort of other primitive collider that kind of fits the shape of your thing, but that can slow things down. There's some other details that, again, I probably won't get super into. But yeah, physics is another big contributor, culprit of frames. Yeah, I think, did I say I was going to talk about something else at the end? Testing, I guess I could mention testing. Yeah. It has a built-in test runner because you can't run the tests in like Visual Studio because it relies on the game engine too much for a lot of it.
Yeah. One thing I kind of think of is like if you're trying to test a web application, a lot of times you actually want to go in and use something like Selenium to actually like interact with the page itself rather than just testing the JavaScript. Kind of like GUI testing. You make a bot that like plays your game.
I mean, I think you can do some of that to an extent. I haven't looked into like the whole higher level testing, but there's definitely stuff you can do. Yeah. But yeah, they do have play testers for a reason. It's hard to catch every edge case, But yeah, so I've mostly done like unit testing with it, which is again hard because you've got to try and split as much of your logic from the mono behavior as possible. They like suggest just having mono behaviors call some other class and then like passing in different interfaces that the mono behavior implements into that class to like call stuff back up, which is like a pain when you're writing small little things and you feel like you have to do that, but that's the way they do it. And it's a pain when you can't freaking drag interfaces over to the inspector and yet you want to use interfaces for all this stuff. Whatever.
That's also kind of a common pattern for those who've taken 376, kind of the idea of separating the GUI from the model, and just generally good at design patterns.
Yeah. Let's see. Yeah, there are no tests in here. I don't feel like writing one right now with like 7 minutes left, but they'll all show up in here and you can just run them all. And again, they won't work in Visual Studio or anything, so you've got to do it in here. Yeah. I guess questions?
All right. Yeah, well, my computer.
So first of all, thanks. It's awesome. Do you have questions here while I try to get the audio back for?
Hopefully that wasn't too scatterbrained. I had like a rough script, but I was kind of going with the flow.
Any questions on our end? Oh, by the way, also while we're doing questions, make sure you take a look at the poll. Poll results are coming up soon, so make sure if you haven't looked at the poll, make sure you vote now on your phones for the poll. Do we have other questions online?
So it sounds like you've been working on something, or you did work on something. Did you take the video game development class in the spring?
No. This is actually my first experience with it has been my internship over the summer. we're working with augmented reality stuff, which is pretty cool. But we use Unity to develop those apps.
Can you just, for people who aren't super familiar, can you describe what augmented reality is?
Sure. So, well, virtual reality is like a whole world that you're immersed in. Augmented reality takes the world around you and augments it with some sort of, digital information. So like Pokemon Go would be augmented reality. Even something as simple as like, having some sort of, Google Glass, whatever, they're all augmented reality. They just put something, overlay some digital information on the actual world. I'm working with HoloLens, where it actually can map your physical world and like have objects interact with that mapping, which is pretty cool. But yeah, so this is the first. I've been wanting to learn it for a little while, and I poked around with it like just a tiny bit. This is my first actual like solid experience with it.
Cool. Other questions? Kind of interjected my questions while we've been going along, so I don't have any other things off the top of my head. Anybody want to learn Unity, build a game? We've got a lot of developers here that could like all come together and make a pretty cool game. Yeah.
I don't know what to make.
It'd be a fun thing, but like, I don't have any ideas.
That's the hard part. You got.
I'm not like that good at Blender.
Oh,
I do want to make assets.
Do you have Blender on your computer? Like, could you show us real quick?
I think I have it on this one.
So while Luke is pulling this up,
hopefully I didn't delete it to make space. I might have deleted it to make space. I can
you could like
or
a Google image or something like that. But just so for people who aren't aware, so one of the things that Luke mentioned at the very beginning is that Unity is really good for getting objects to interact within the world and making it interact with user input and things like that. But in terms of creating the assets and creating the models and things like that, Unity really doesn't have a lot of support for that, or not at all. And so we have other programs like Blender, or I think I've used Google SketchUp as well for certain things that will actually let you create 3D model files and textures and things like that. So if you're more of an artist, this might be what you're more interested in. If you're more of a programmer, you might be more interested in Unity. So.
Yeah, and this, you can like map stuff to the models, like map textures to the models here. You can do particle systems here. You can do rigging if you want to have animated like characters and stuff, which is pretty interesting. Rigging is a pretty cool topic that I'm very, very bad at. Yeah, it's cool software, and it's like free and everything.
Yeah. I think other software, some of the programs in the Autodesk suite, I think Autodesk Maya or 3ds Max are two good ones too. I've used them a little bit before. Oh yeah, so Eric brings up a good point. So Eric just mentioned in the chat that you can get plugins for Unity that can help with some of the art and some of those things. So yeah, it's definitely really cool stuff. Yeah, other questions?
It's free. There's like a free license, or like free to use for your own use.
If it's like your own use, like when you sign up for it, it asks you things like, do you like work for a company that has like this much of an income and stuff like that? So you can get it for free. I think it still forces you to have like the made in Unity splash screen of the games you make, stuff like that, but it's very functional still. So.
I think if you start selling your game though, and you're just like
professional or
So one of the things that Devin asks is like, is there any integrated support? Like he asks if there's like a Microsoft Paint like thing where you could like go in and make graphics within Unity. I think the answer is probably no. But
you can do things like change objects' colors, change how they're rendered. But like if you once you get into actually like editing images or anything, you can't really. They have like a UI editor, so you can actually like make text and stuff in game, because that's pretty important. But all of the graphics you'll have to do externally and then just import, which like makes sense. It's not their job. It's pretty easy to just even find some cheap photo editor and just import it. But yeah.
Other questions?
And there's a lot of stuff on the asset store, like I said. If you really like even free stuff. there's a lot of free options. Best way to find free stuff. Free packages like that. It's like, you know, assets, random assets, 3D game kit. I think that comes with other tutorials, that kind of stuff.
So if I wanted to go online and learn a little bit more, what are some good sites to go to or some good resources?
Unity itself has a lot of great tutorials on, that's where we started. Let's see. They have a nice little tab for it on their website. And a lot of them you can actually just download a lot of the assets through the Unity Asset Store or whatever.
Okay.
And then you'll have the assets in your game and you can mess around with whatever. And they have 3D ones and 2D ones. These ones are, they tell you to start off with these. I didn't think they were super useful. I'd start with like this one. This one's like way more useful. But yeah, and then they get more complicated. This one was super useful. It's kind of long. The videos are kind of long. But it's
entire day at a convention.
Yeah, but it covers a lot of topics. Like it covers like camera movement, doing the whole prefab, making a couple of instances thing, you know, player movement, some lighting. So it was just very, very useful. So yeah.
A lot of UI stuff in there, just
A lot
like
of UI
surrounding
stuff.
the 3D objects.
Like game world UI and like screen world UI.
Kind of like a HUD or something like that, yeah.
Like there was, I think it was specifically like game over type splash screens, and then
Okay.
also a little floating health bar on the tanks themselves,
Okay.
which was like good coverage of topics.
Devin asks, are the graphics provided in the tutorials? Like, are those assets provided with the tutorials?
Yeah, for like all of these, all the official ones at least, they'll just have them for you, and it's pretty easy to find placeholder graphics, you know, that come with the cubes and spheres and whatever. But yeah, all these give you these kinds of things.
You can download that Unity initial like controller when you open up new projects.
Oh yeah, yeah.
You can download them all there.
Yeah, there's like an opening screen where you select projects when you first launch it, and there's actually a screen to like download some tutorials that have like assets packaged. And a lot of the assets are like, let's see if I can find one. A lot of them have their assets like in the asset store. This will be in here, might not be, now that I've said that. Oh yeah, there it is. So like it just has, Jake's tutorial has all the assets for you.
Gotcha.
Which is nice.
All right, so we're going to go ahead and announce the poll results. So we had, I think, 12 contributors to the poll, which is good. We got 10 contributed answers. So the question for the poll was, which text editor do you prefer? And we had a tie between Vim and Magnet and a Study Hand. So two good text editors there for you. So I won't switch back to my slides, but I'll talk a little bit about next week. So next week, I think Travis is going to talk to us about some Node.js. So that's going to be some exciting stuff there. I do need somebody to do cool news. So anybody interested, coming up with some cool news content for next week? Okay, just let me know. So if you'd like to volunteer for doing cool news, Tom, how long did it take for your cool news, like to do the research?
I don't want to say how long it actually took because it was half an hour that it actually took me. But I probably should have made it more like 45 minutes.
Okay.
I would have found out my mic didn't work on my computer then.
But yeah, you don't have to. I mean, like you could find just like one or two articles. I mean, as long as you find something that's interesting to you, and that's quote at least tangentially related to software, it'll be fine. So that's all we're looking for in terms of cool news. So with that, I think we're gonna go ahead and end it. Thanks, guys.